As you saw in part one, the vocals were tracked with fairly aggressive printed compression, so I only need a further 3-4 dB of gain reduction in order to properly pin the vocal signal down and keep it intelligible within the context of the very dense mix. I'm using the UAD Fairchild 670, a valve compressor, which is also introducing some further vibe and colour to the vocal signal. Lastly, on the vocal sum, I am using the UAD SSL G bus compressor, which has been set up with a 3 millisecond attack time, somewhat between the attack settings of the first two compressors, and with a 4:1 ratio, auto release setting, and it's delivering roughly 5 to 6 dB of gain reduction here. So collectively, this series compression approach introduces coloration from each of the different compressors, providing a really full and upfront vocal sound. From a vocal EQ perspective, there are a few areas of resonance being taken care of with corrective EQ here, and a touch of low end introduced around 160 Hz, just giving a fuller, thicker vocal sound. It's really important that the vocal has comparative brightness to the rhythm guitars. To enable this, I'm applying a broad, high shelf boost from around 5K. Vocals effects wise, I've combined a number of different reverbs and delays, and I've also applied pitch thickening width enhancement and also some parallel distortion treatment. First off, I have a plate reverb as well as a fairly long room reverb. Then I'm using a mono slap delay, an 1/8 note delay, as well as a long multi-tap delay line. The pitch thickening width enhancement comes in the form of 2 mono return paths, with one pitch shifted up by 8 cents and with a 16 milliseconds delay time, and the other pitch shifted down 8 cents and with a 24 milliseconds delay time. So the delay times here are roughly in the ADT, automatic double tracking region, of around 20 milliseconds, but with sort of 8 to 10 milliseconds difference between the two, which gives it this stereo widening effect. The mix is really taking shape now, so I'm moving on to some automation just to provide a more dynamic listening experience. So I've emphasized the level of the kick for the first hit of the song and also for the first hit of the chorus. I'm also moderately emphasizing the level of the rhythm guitars and also the cymbals during chorus sections. I've spent a bit of time automating the toms just to make sure that all the hits are perfectly audible and at equivalent level. And I've also used longer reverb times and greater reverb levels during slower drum performance sections where there's more space. I've spent a bit of time riding certain bass notes to create interest, and I've also increased the level of the bass reinforcement distortion channel during the chorus just to give a bit more excitement at these points. And then lastly, I've highlighted end of line sustained vocal notes with a little bit of additional reverb and delay just to help carry the note. Moving on to the mastering stage. Firstly, I'm applying the Manley Massive Passive mastering EQ with a high pass filter at 39 Hz, but also using a moderate low frequency shelf cut, only just half a dB at 68 Hz downwards, just to moderate some of the sluggish content down here. Other than that, there's just a touch of low mids being attenuated at 270 and a touch of brightening from around 8K upwards, which is putting some sparkle into the air frequencies of the mix. Moving on to mastering compression. This is an area where many people overemphasize the importance of multiband compression, which is a great tool for solving certain problems. For example, gain reduction in the lows causing unwanted modulation in the highs. But with a mix that is well controlled in the first place, especially in the lows, broadband compression often provides the most effective approach. I'm therefore starting with the Shadow Hills mastering compressor, but just using the VCA side of this compressor. I'm using a 10 millisecond attack time and a fairly fast release, collectively delivering around 4 to 5 dB of gain reduction. From here, I'm introducing just a touch of analog warmth via the UAD Ampex ATR 102. Lastly, I'm applying the Oxford inflator to limit the production. Fortunately, the inflator is only providing around 4 to 5 dB of gain reduction during peaks. Unfortunately, the algorithm of the processor is enhancing the program loudness in a fairly natural, non-detrimental way. Let's have a quick listen to the final recorded, mixed and mastered production. Thanks for watching. Hope you found some useful information here. To find out more about our taster days and when you can come and visit our facilities, please visit hud.ac.uk. Hope to see you soon.